was incredible. I've never been to a rainforest before, so walking into this forest was so different. I thought it would be North Queensland and it'd be hot, and then you walk in and it's cool and there's green everywhere and it's really peaceful.
Well, this is the first time I've ever been to the Daintree rainforest, and I was just blown away by it. It's absolutely incredible, absolutely amazing.
When we were told about it at school, I thought it would just be sort of a school trip thing. People going up, you can have this job, do some paperwork maybe, but we're actually starting our own thing. We are making our own science.
What we're trying to do is get a picture of what the rainforest looks like. So we're not trying to do an accurate assessment of species composition, we're just looking at something that's called structure of the rainforest, and that's based on percent cover, it's based on numbers of trees and the size distribution of trees in a particular area.
Some snakes to keep an eye out for. Red-bellied black snake's probably one of the more common venomous snakes that's active during the day.
So if we can provide a platform for something that would be a bigger study, then that would be, from our point of view, a really big contribution and a wonderful thing for students to be involved in, because students these days want to feel like they're contributing something real.
A lot of the things that they were talking about in the seafood briefing, most of them are common sense. Don't eat the berries, don't touch the spiky plants, but there's all the different spiders that can be lurking anywhere, the snakes and everything like that.
When I first entered this rainforest, I was a bit hesitant at the start because I didn't really know what to expect.
You walk in and you're inside it. It's like you're trapped in there forever. It was just so beautiful and calming and such a different world from everything else. It's so enclosed, a world in itself.
David, who was one of the scientists who was helping us, he was so much help with us identifying the seedlings, because when we first walk in it's just like all the leaves look the same.
They may be abiotic, so maybe it might be soil or... I'm helping these guys setting up their transects and directing them in the correct procedure in order to carry out their assessment.
How many transects would you have to do to really represent the diversity, do you reckon? Like how big is sample size?
Yeah, I think it depends on what you're measuring. I know what I'm looking at now is ecological condition, so it's measuring the health of a terrestrial ecosystem. And they recommend you, and they're quite large transects, but they're measuring quite specific things.
The transect we're using is a line transect, and it's really just a long line that runs through, in our case, through the rainforest. It's a point of reference.
Oh, nice.
Before we'd done a little bit of walking through here, but there was a lot more open space. Here, so much more compact. And along those walking tracks, the guides really know what they're doing, which each plant is, which ones you can't touch, which one where the really dangerous plants are. Here, they're just like, they're everywhere. And then walking along there's a lot more spikes on the vines and everything like that. There's plants hanging all over, there's branches sticking up, and there's roots everywhere, and there's really rocky terrain. And then there was the creek that we had to cross over where the rocks were really mossy. And the first time I slipped and landed right on my bum, and it really hurt.
Tomorrow you guys have to set up 2 transects, and at this point I think what the approach is going to be is have one close to the creek and then one further away from the creek. And I guess like the reasoning behind that is you possibly pick up some sort of difference in species composition and also the structural composition of the different plots. A transect is a predefined area that scientists use in these sort of studies that serves as a representative sample of the ecosystem you're interested in. You guys are breaking up into different groups. You'll know what you're measuring. So can you give me an example of something that you'll be measuring?
I'm going to be counting funguses.
Funguses, all
Yeah,
right.
they're really pretty in this area. They've got all these like lattice structures and they connect to logs and because they're really good for decomposing all the logs and stuff, and I've heard that there's going to be a lot of that.
Yeah.
I'm really looking forward to that.
Yeah, cool. And so I guess that's an indication of how well things are decomposing in the forest. Yep.
We're also doing.
We did lots of preparation. We researched a few species of plants that were more special or more common or more endangered, and we're going to focus on those plants so we can see what happens to them. We did species profiles that we created, so that's what the seedlings look like, what the adults look like, what the leaf shape is, what the fruits and seeds look like.
And I guess you would have had to have done a dry run of the process. I mean, even if you didn't have, a rainforest to do it in, you had to.
Yeah, we went out at lunchtime and on our oval tried to set up a transect with all this. It was a very big learning curve.
So cool.
I have to get you to cut it.
So yeah, you look through it and you'll see the line because you stereo vision. So it's slow.
Don't have to get hot oil, but not get oil.
Everyone know what we're doing this morning? First job is
Transect
setting up the transects, okay? This is not going to be quite like setting up a transect on the football oval at home. It's going to be a little bit more difficult, and how difficult it is depends on how much scrub there is and how much rock there is and what kinds of things we've got to go around. So we're really going to just have to play it by ear.
To get to the experiment site, we have to first go through a bit of a path in the forest, which is all good. It's carefully paved out. Then we have to cut across just 10 metres, cross a bit of a creek, climb up a small hill, and then we're at our site.
We've got to put the pointy end in the ground.
First, we had to find the place. We had to figure out an area that would be most interesting with the different plant life and the different types of plants. So we decided to go from the river, going away from the river.
I was actually the one who put the first, banged the first pole in, which was lovely because, it's down with the buttress roots, and we were just talking about before with the buttress roots, that's where the snakes like to wait for their prey. So I was just like, I'm just standing here in a big snake nest, it's fine. It was, thrilling.
We set up a big, long 50-metre line in the middle, making it as straight as possible, and put stakes at either end.
All right, so that's 50 metres in a straight line there. Just flag it and then we'll measure it out perpendicular.
So then we did 10 on each side and 50 up again.
So basically just get a rectangle, which is like a cage, if you want to think of it like that, so that we can take information from different sizes of trees, different species, different sizes of seedlings, different fungi, things like that. Unfortunately, we had a bit of a mistake up here with the outside of the quadrant, so we're just running 10 metres across each side, and to get 10 metres each, we'll flag it on that side, flag it all the way down, and then run our quadrant straight back up again, and hopefully it's correct.
In this case, the transect has 3 nested plots, a larger, a medium and a smaller plot. Within the smaller plot, you're looking at medium-sized trees. In the very small plot, you're looking at smaller trees. And within that, you're looking at a number of ground cover measurements, which are measured using a 1 by 1 metre quadrat, which is a standard practice in these sorts of assessments. And also they're doing a count of seedlings of 5 common species within the rainforest.
We're really trying to find out, first of all, what these plants are and how many of them there are and what's the distribution and what type of plants there are, because no one's really discovered that sort of stuff before.
So basically what we're going to be doing is monitoring seedlings around here, so that's just small plants. We've got 5 to look after, and instead of using the science names, we're just going to be using the nicknames. So we've got Meg, Andy, we've got Placey, we've got Norman, and we have Mo. They all look different, and if you guys get stuck, information's in here.
We have our seedling Bible.
We do. These tags you have to put loosely around the base of the seedling so they can still grow.
Every seedling.
Every one that is one of the 5, so clearly there's going to be seedlings that we don't know. To measure the data with our little trees, you first measure the height, and so if they're less than 1 metre, they qualify for a seedling. There we go.
16 centimetres.
Yep. You measure how far away they are from the middle line, which it has to be less than 1 metre.
Okay, we're good. 75. Yeah.
You measure their width. You measure how far they are from the base of the transect, so how far up the 50-metre line they are. And you have to take photos of them so that future generations can compare what they look like.
Oh, it's another deal.
With the trees, we have these really fancy tapes. You put them around the tree at breast height and it gives you the diameter instead of the circumference. You have to go up and down to make sure you don't miss any trees, measure them, write them down, record what type of tree they are if you know it, how big the diameter is, where it is in the transect, so that when people come back next year, they can find the same tree.
We change over time.
Well, we're going to get in the way of the filming. So we found a Chrysanthus myrrianthus, and Bella, how do we know it's one of them?
So the characteristics of this plant is that they've got little scars down here where it connects back to the stalk, and also they've got a lighter colour on the underside of the leaf.
You'll also find
It's really, really incredible to have this experience, and it's so different seeing the plants and seeing how different they are than just Googling some photos, and you get maybe 1 or 2 different types, and then here you realise that everything's different and you see how everything's connected to each other.
This is a Endiandra micronura, or Endi for short, which is what we're going to think of. It's the 6th plant we managed to tag. Right, how far away from the transect is it?
I've never done this kind of work before, but I did feel like I'm doing something here, doing something important that's going to be very helpful to other people, to other sciences in the future. And especially for this area, the Daintree rainforest is a very important area for Australia. So I did feel like I was doing something really helpful, and it felt really good.
We're all split up into little groups so that we can analyse the data better. But at the end, we'll all collate our data together and try and make sense of it. But if we can't, we'll just send it to other researchers who will be able to mix it in with their own data and get a better idea.
So can you imagine doing some measurements up here? Like putting out a plot, or, I don't know, taking measurements of the canopy of certain species?
Yeah, putting up a plot here would actually be pretty awesome. It would be pretty easy to know where to put the plot because you'd be able to see all the trees from up there.
Going up in the crane and just seeing it all, how beautiful it is, it just makes you feel like, yeah, I want to conserve this, I want to make a difference, and want people to know that this area is a very special place and that we can't just go randomly chopping it down. So yeah, it definitely inspired me, yeah.
It's important what you guys are doing because you're I mean, essentially you're scientists now.
Yeah.
So, you know, like whether, I mean, you might have formal training, but you're, you know, students, you're citizen scientists. So the work you're doing on the ground is something that can be replicated by other researchers.
Yeah.
They can do those same recordings somewhere else in the rainforest and get some idea of the variation across geographical distance, so they can use certain measures in order to see, you know, how different one plot is from another.
Oh, it's so important. This is like the oldest rainforest on Earth. I want to see it when I'm older. I don't just want this to be something that I have there when I'm 16. I'd love for this to be able to grow and keep getting better, because in the past, humans have treated this horribly, and I want to change that. I want to be able to make this a better forest.